Well, today we want to give the drafting environment a little attention. Drafting, of course, is one of the four main modules of Cimatron, along with parts, assemblies, and NC files. It is the documentation arm of the product, not really used for creating new geometry, but ideal for describing it. And while not everyone makes full detailed drawings anymore, drafting still does have a very important niche to fill in our industry. So if drafting is an entire Cimatron environment, how can I possibly cover it all in a 20-minute webinar? Well, I really can't. But what I think you'll find useful today is to see some basic functionality for views and dimensions, and then contrast that with the more automated ways to use drafting more efficiently. Because it's important to know both the basics of how something works, but also the shortcuts you want for speed. For example, to start a drawing of a part, you need to make a view of it. But for quickly making a full drawing, you'd be better off using the multi-view function. And there are some other tips we can look at today too. Let's start with one of the most important choices drafting needs you to make. I want you to look at these two drawings of the same slide and notice the differences. The look of the dimensions is a bit different, absolutely. But more importantly, the layout of the views is not the same. The drawing on the left was made with third angle projection, which is what is taught in North America and probably seems normal to my audience today. The drawing on the right was made with first angle projection of views. And this is how drawings are made in Europe and some other areas of the world. But for those of us used to third angle view projection, first angle projection seems very backwards. The view projection and the dimensioning style, as well as other things, are all controlled by the drafting standard used by the drawing. ANSI is the typical North American standard, whereas ISO is commonly used in Europe. And this is really an important distinction, because if you are using the drafting standard that's foreign to you, nothing in Cimatron drafting is going to seem very comfortable. Let's jump into the software and start a new blank drawing in inch units. Now the drafting tree on the left shows right at the top the current drafting standard, and in my case it's ANSI. And that's not because I selected to create an inch drawing. The drafting standard and the units are totally unrelated. It's because my drafting preference is set for ANSI. Now you can change the standard right here in the tree, but because it's a preference, let's go to the preference area, talk about this, and a few other significant preference settings. Drafting has its own section in the preferences, and the ANSI ISO toggle is down here in drawing and sheet settings. So you want to set that to ANSI and then save it as all application so that all future drawings are set up correctly. This is also, by the way, where you can choose to have every drawing start with a frame. So a default frame would be the drawing border and a title block. There's a list of them here. We could talk about frames in a minute. Other preferences, the different types of views have some preference choices, scaling, and whether they should be named or not. I encourage you really to look through all of these if you're going to be doing much drafting, because good preference settings save you mouse clicks and time. The other one I'll mention though is under General, and it's the page about dimensions. So this is where decimal precision and other factors about dimensions are set. I would consider this one an important one to look at and have it set correctly from the start. Back in the drafting tree, it's going to show you how many sheets you have. So far there's just one. And then under each sheet, how many views you have on the sheet. So far there are none. You want to think of a sheet as a piece of paper. It's an infinite space, and so really you can have as many views as you want, but you can also make as many sheets as you want to. So organize all of this how you prefer it best. Also at the top of the drafting tree is a window for view attributes. And this holds the default display settings for each of the views that you're going to make in the drawing. It certainly holds a lot. Every type of line style and color can be set in here. So for example, if I know that most of the time I want hidden lines on in the views I'm making, this is a good place to make that change, or anything else. Now this window is also found in the preferences. And it's going to be available underneath each individual view that you make. So you really have total control all the time. Under each sheet, you're going to find a spot for applying a frame. Instead of none, just get to the list and choose one from the list. A frame is like a special overlay on the sheet, and everything to do with them happens from this one frame settings window. Here's where you can make new frames and save them. Or you can edit existing frames. Or if you get a title block from someone else via DXF, you can import that and save it as a frame. So you certainly aren't stuck with just the few defaults provided from Cimatron. You definitely want to set up a few frames for your company. On the right-hand side of the screen are the tools for drawing wireframe. Any Cimatron user will recognize these as the same functions that are found in the sketcher. And that's what they are. But really, you should rarely need to use these. Like I said earlier, drafting is for documenting the parts you've already modeled, not to draw new things. And that's the basic layout of the drafting environment, so let's get into creating some views. The first thing to do in the View Feature Guide is to pick the part or assembly that you want to detail. Once that loads, one click on the screen will give you the view preview. But really, you should take some time to know what all the options in this view dialog are. For example, you can set the view scale and the view rotation. Or you can change from the top view to any other type of orthographic view. And there are other areas here for showing PMI and modeling or part filtering or a lot more. Most of the time, your next view is going to be what's called a derived view, meaning you're going to flip it off the first view you placed. And this takes only 2 mouse clicks. First you pick the source view, and then you position it on the screen where you want it. And that will work time and time again as often as you need it for. Derived views are naturally aligned with each other, so you'll find that when you move one, they're all going to move. If you do ever want to just move one view without affecting the others, I have a tip for that. You need to drag the view while holding down the Alt key. That breaks the alignment. Or, like in modeling, you'll find that there's a lot of options when you right-click the mouse. One of them is Remove View Alignment. And this is also the place where you can add alignment too. So if I want to fix the view I just moved, I just have to ask it to align horizontally and then pick the view I want to align with. That works for unrelated views as well. You can still align them. Now, of course, single views don't have to be derived views. Even though you can click on the screen to load the model, to get something besides a derived view, you just come back to these orthographic view options and pick. And there are quite a few on the list, different ISO views, etc. Let's change the scale a little bit here. I think the neatest one is the dynamic view orientation. So when you go into this mode, besides several options you have here, you can just hold down the Control key and rotate the model just like you would in the modeling environment with ZPR. And you'll also notice while in this mode, the preview is of the shaded model. Once you apply the view though, it's going to have the attributes from your global settings. But that doesn't mean that's what you're stuck with. As I mentioned earlier, each individual view has attribute control. And one of the things you can do in here is to set the view to look shaded. Let's have it as model color and turn a few other things off that get in the way. So while creating individual views is pretty easy, and it's important to know how to do it, there are a few ways to do it even faster. Let's create a new sheet and then duplicate the layout we just made using the multi-view function. Multi-view creation just means making all the views at once. The dialog is a little different, but still works in much the same way. You still have to pick the part. The preview of the views is on the screen here. The preview is shaded in this mode, but they'll still be made to the attributes like before. And then this area of the dialog helps you set up which views you want in which location. If you have a layout that you're going to use a lot, the thing to do is to save it as your favorite multi-view setting so you don't have to mess with this every time. Also, there's some global control for attributes, so let's go into here, for example, to turn hidden lines on. I can still do something like set up my ISO view when I'm using multi-view creation. And there are ways to set attributes and things away from the main dialog settings. So let's come in here and turn down the shaded. And it's also where I can use the interactive ISO. So I still have that option even when using multi-view. Views made with multi-view are still aligned. And for the few things that can't be done by multi-view creation, of course you still have access to the individual views to set certain options. So that's pretty quick, and multi-view is a really nice way to set up a drawing quickly. I'm going to go back to our first sheet, and before we move on to dimensioning, let's look at a couple of the types of special views and a few tips that go with them. Sometimes you need to derive a view on an angle to show a feature at true size and shape. And that's easy to do, but it requires one extra step. You start by picking the source view, like any other derived view. But the next click is to pick the angle to flip the view about. And you have to turn on the edges filter. You also have to have a flat line to pick from, even if it means zooming way up to find one. But then you place the view. The view will still be in alignment, and all the other options like attribute control are still available. Now in my case, the full view is not really what I want. I just wanted to show a small part of the part detail on an angle. And that's going to require me to clip this view back. Clip views, detail views, and local sections are all types of views that first require the use of the contour function. And a contour is really just a sketch, but it belongs to a view and then sets up the relevant portion of the child view. A contour can be any size and shape, but the tool does default to a circle because that seems to be the most commonly used. Making the clip view is just a matter of using the clip function and selecting the contour. It's worth mentioning that contours, like any sketch, are editable. If they change in size or shape, then the view based on the contour will change as well. Another use for contour is local section. Local section is a little different than a regular section view in that it applies itself on top of an existing view. It's not a new view in and of itself. In local section, besides selecting the contour, the other requirement is to set the depth, which you can do by keying in a number or by selecting a point from a neighboring view. which is a really nice way to make sure that you're drilling down into the correct level. Section views and local section views always do the cross-hatching automatically, but there is a hatch function, and you can edit an automatic hatch. So in here you're going to find the usual hatch options, like size control or different hatch patterns. The last use for a contour is for making a detail view. Detail views are for areas that need to be blown up for better viewing. Unlike clip views or local sections, detail views have no special function. You just use the regular view tool and then you select the contour. The system assumes a detail view in this case, and then you can place it on the screen. Usually at a larger scale for clarity. A detail view is subject to the parent view, so if it changes or if the contour changes, the detail view will update. And as I hope you're aware, all of the views in a Cimatron drawing are subject to the part model. So if the part model gets changed, the views will update to reflect that. Okay, now let's talk dimensioning. The unique thing about dimensioning in Cimatron is that there's only one function to do every style of dimension. So it's very important to know just how to select the geometry in order to get the result you want. For example, with a simple linear dimension, all you have to do is select the 2 points or lines and then drop the dimension on the screen. The feature guide for dimensions has literally dozens and dozens of options in it for text, tolerancing, line style, and other ways to control the look of the dimension. And something new is the ability to save a certain look of dimension as a style, which makes it easier to create groups of similar looking dimensions. Radial dimensions happen automatically when the entity selected is around. And something not very well known about radial dimensions is that if you double click around, then the system will give you a diameter, even though the entity is an arc. And the opposite is true. If you have a full diameter and double click it, the system will dimension it as a radius. When dimensioning a thread, the system will call out the thread type. This happens because in the feature guide, the option for automatic tap is checked on. So even though the feature guide changes somewhat based on the type of dimension being made, in every case you're going to find a lot of different parameters that offer total control over the dimension. If you select a dimension from 2 points, the system will assume you want either a horizontal or a vertical dimension. But if you select a line before dropping the dimension on screen, then you get the dimension normal to the line. And then there's ordinate dimensioning, which is a really great way to communicate information. But we get a lot of questions on it because the clicks to make them are not always so obvious. So how you do it is first click on the 0 origin point for the string. Then you select on the screen up or down or side to side, depending on the direction of ordinates you want. Then as the third click, pick where you want the dimension. Often this is also the first pick so that you get a 0 dimension, but it doesn't have to be. After that, just keep clicking points and using the middle mouse button to confirm. So at this point, you're making a string of ordinate dimensions. If you get out of dimensioning, you can always edit an ordinate by double-clicking on it, and you're right back in the string. If you add one where there isn't a lot of room, the system will automatically jog it, which is adjustable. And you can also do some other things from the feature guide, like set the text to be free if you need to move it out of the order of the other string. Moving over to notes, these are all made with the text function. This function is fairly intuitive. After selecting a point, you just type the text you want on the screen. Leaders are optional. And like the dimension feature guide, the text feature guide has a host of options in it to control the look of the note, and these can be saved as a preferred style. For more text options, clicking in the box in the feature guide opens up a text editor. And this has even more controls in it, like special characters. Plus, the text editor is where you will access the list of available symbolic text. Symbolic texts are linked to part or drawing attributes. They're automatically filled out. On the list, you can see that many of them are related to the electrode package. But there are several here that you might use often. For example, you can get a note that communicates the scale of the view. Most symbolic text will still show the variable name on the screen until you tell the system where to find the info. And this is done by attaching the text. You use the attach button and then select the view that will supply the information, and then approve. This step of attaching the text is absolutely necessary for any symbolic text that links back to a part attribute. So you have to consider that attach a key step in order to get your symbolic text notes to work. So is there any automation for making dimensions or notes? There is some, yeah. Let's try a few over on sheet 2, which is cleaner looking. And I'm going to start at this toolbar up at the top, which has several automatic functions, one of which is automatic ordinate. Automatic ordinate dimensions work especially well in top views which have a lot of circles in them. So the feature guide for this function has several options that you can set. Postfix, where the ordinates come out at, and then you'll see that the geometry filter is set to look for circles automatically. But it can do other things like arcs or even manual points if you want to pick them. The only mandatory step is to pick the center point for the ordinate dimensions and then let it run. So like most any automatic function, several assumptions are made to speed up the process and make the interaction simple. But every dimension that this function makes is still a unique ordinate dimension, which means you can still edit them one at a time and make any adjustment that you need to. And you're certainly time ahead by creating ordinates automatically as opposed to making these one by one. Another time saver is the table of holes function. That would show better if I had a view where the holes were most prominent. So what I'm going to do is derive a new view from the bottom and then turn the hidden lines off. Because this block does have several holes in it, it lends itself fairly well. The options in table of holes, again, the feature guide has several. So let's set a few that work better here. Other options include where you want the origin to be. When you're picking the view, you can just choose a coordinate system or physically select a point, delta, and then position the table on screen. In the table, every type of hole is called out as a group with dimensional information plus descriptive text. Usually, along with the table of holes, you'll also use the automatic label of holes. Once again, several options to help automate the process, but if we just let it run, what we'll see is the numbering that this function uses matches the hole table. These two functions communicate with each other and usually work very well when used together. And that's really all I have time to cover for today. Cimatron drafting has other good features in it, but these basics will get you started, and the automated tools can help you be more efficient with your detailing.